Every founder hears the same advice: rent an API to start and then self host your own GPU to save money. So we actually tested it. We ran one model with the same prompts across all three approaches and compared the real bills. Here is what we found. A single GPU you run yourself does get cheaper per token than serverless, but only once you keep it genuinely busy. The catch is that early stage traffic is spiky and bursty. So most startups keep a GPU only 5 or 10% busy. And down there, serverless is 2 to 4 times cheaper and zero ops. So the real question isn't serverless versus self-host. It's how steadily busy is your GPU actually going to be. Let me show you exactly where the line is. Three ways to run the same model. Serverless. You call an API and pay per token. The provider owns the GPUs, the scaling, all of it. You manage nothing. Dedicated. You rent a whole GPU's worth of capacity kept warm for you as a managed endpoint. You get isolation, the provider still runs the box. Self hosted. You rent a raw GPU and run the model server yourself. Or in the extreme, you buy the hardware. Most control, all of the responsibility. Judge them on four things: cost, latency, how they scale, and how much operational work they put on you. To keep it fair, we fixed the model, Quen 332B, and two realistic workloads: a chat shape, lots of generated text, and a retrieval shape, a big document stuffed in with a short, grounded answer. The prompts, the streaming client, and the metrics all stayed identical. The only thing that changed was the deployment model. The first setup is serverless. The second is a managed dedicated endpoint. The third is self hosted. We rented a GPU and stood up vLLM ourselves, both from a ready image and fully by hand. Note, on the GPU we ran full BF16 precision, while the managed services run their own build, most likely the faster FP8. That works against our self hosted numbers, so when self host looks cheaper later, it would look even better matched apples to apples. The first difference shows up before a single user arrives. How long until you can serve and when the meter starts. Serverless was live in minutes. You grab an API key, paste it into your app, and you are live. You pay only when tokens flow. The managed dedicated endpoint took about 20 to 25 minutes to provision before it answered one request, and you are billed for that whole warm up. That wait is normal for a large model. Managed endpoints across the industry take anywhere from 5 minutes to half an hour because the platform has to pull and load tens of gigabytes of weights. Renting the raw GPU yourself was actually faster, roughly 4 minutes to a serving endpoint. But then you own everything: the firewall, the drivers, the container, restarts, teardown. We learned that the hard way twice. A port quietly firewalled off our endpoint, and a deleted managed endpoint left an orphan GPU still billing until we hunted it down. For a single request, a GPU all to yourself is clearly faster. Measured the same way over the public internet, one stream on our own MI300X ran about 50 tokens a second, with first token in roughly 6 tenths of a second. Serverless sharing a pool was slower per stream, around 22 tokens a second, with first token closer to a second and a half. So dedicated is about 2.5 times snappier to first token. But that's only while it's lightly loaded. Push that same single GPU harder and throughput climbs while latency falls apart. At 32 parallel requests, it still felt fine, around 15 seconds end to end. By 100 plus, end to end crossed 30, then 40 seconds, and the slow tail got brutal. Keep that in mind because it changes where self host actually pays off. Here is the number everyone actually wants, and it's easy to get wrong. So we are doing it per answer. A typical answer here is 1,000 tokens in, 500 out. On serverless, that costs about 500ths of a cent, and it never changes with how busy you are. A rented GPU is the opposite. You pay for it by the hour, whether it works or not. So its price per answer is all about utilization. And there are two things people mix up here. One is duty cycle, what share of the day the GPU is actually working. The other is concurrency, how many requests you run at once. Duty cycle is what sets your cost. Concurrency is the knob that trades latency for throughput. Run the GPU flat out. high concurrency, and one MI300X handles almost 5 answers a second, about 1/100th of a cent each. That's roughly a fifth of serverless, but flat out means 40-second responses. So there are two break even points, not one. If you saturate it, you break even at only about 22% duty cycle, but answers crawl. If you keep it snappy around 15 seconds end to end, you break even closer to 50% duty cycle. It sounds backwards, but saturating breaks even at lower utilization than staying snappy because higher concurrency means more tokens per working hour. Either way, the message is the same. Once a single GPU is steadily busy, somewhere between a quarter and a half of the day, it beats serverless on price, and well above that, it's several times cheaper. And to be clear, keeping it busy is not the same as maxing it out. You can sit at the snappy operating point and still win on price as long as the GPU isn't idle. The trap is the other direction. At 10% duty cycle, where a lot of early GPUs actually sit, self-host is more than 2 times serverless. At 5%, it's over 4 times. And that idle GPU still needs you to babysit. So the cost win is real, but it's a win you only collect by keeping the thing busy. Two footnotes that matter. One, managed, dedicated, and self hosting run the exact same silicon. So they perform the same. The managed endpoint just cost about 30% more per hour, which moves its break even from around 22% up to roughly 29% duty cycle. Still a low bar, but you are paying that premium purely to not manage the box. Two, buying the hardware. Model it honestly, capital spread over 3 years plus power, and an owned accelerator is cheaper still, a small fraction of serverless when you keep it busy. But two big asterisks. You can't actually buy a single one of those MI300X cards. They ship in 8 GPU servers. So this is an illustrative model, not a price you can put on a card. And it only pays off if you sustain that load for years and have the cash up front, and the part nobody costs, have someone on call for it. For almost every startup, that someone is too expensive. So here is a rule we would give a startup. Default to serverless. Pre-product market fit with spiky, unpredictable traffic. It's both the cheapest and the least work. You pay essentially nothing when idle, and it bursts for you. Move a workload to dedicated or self hosted when you need something serverless can't sell you. Tight, predictable latency, isolation, and guaranteed capacity, or data that has to stay in your boundary. Notice that's a control decision, not a savings decision. Chase the cost crossover when you have steady, predictable base load that keeps one GPU at least a quarter to half busy around the clock. That's when it genuinely undercuts serverless. Self host before you buy, because renting is the same speed for 30% less and no capital. And put a thin gateway in front of all of it, so when you do move a hard path to dedicated later, it's a config change, not a rewrite. The traps we saw firsthand: buying or reserving a GPU to save money and running it near idle. At the 5 to 10% utilization, most early GPUs actually see that's 2 to 4 times more expensive than serverless plus the ops. Forgetting the warm up and idle bills. The dedicated endpoint charged us for 25 minutes before it served anything, and an orphaned GPU kept billing after we thought we would shut it down. And measuring wrong, which bit us twice. Our first throughput test, run over the internet from a laptop, underreported the GPU by 3 times. And early on, we compared costs on output tokens against a price that also bills input tokens, which made self host look worse than it is. Both times the fix was the same: line the numbers up honestly. If you benchmark, saturate from close to the box, and compare cost per answer. The takeaway is simple: optimize the model choice and your utilization before you touch the deployment model. Default to serverless and move to your own GPU once it will actually stay busy. And don't guess your inference bill, measure it carefully.